Hello, my name is Barrett Moody. I'm in Physics 2211, and this is my fourth lab, oscillations. So the purpose of this lab was to investigate the 2D motion of a spring mass system. So it's moving in both the X and the Y direction, unlike the image on the right, which is only moving in the Y direction. Utilizing tracker, we observed the motion of a spring mass system and then compared its motion to that of a computational model using GlowScript. We measured the positions of both the tracker model as well as the GlowScript model, and then we observed their changes in energy throughout their motion. And we concluded that we saw it remained constant, abiding to the energy principle. The fundamental principles in this lab were Newton's second law as well as the law of conservation of energy, also known as the energy principle. So Newton's second law was used to determine the system's change in momentum with different forces applied, which we could then use as like a position update formula to pinpoint where the mass would be at the spring mass system. Lastly, the energy principle was used to measure the changes in the kinetic and potential energy as it ebbs and flows and goes throughout its oscillation. This is our glow script for the spring mass system. The first thing that we changed was the mass of the ball, it's 0.402. Then the ball's position and initial velocity, which we both got from tracker. We then uploaded our constants of gravity being 9.8, our spring constant being 6.81, and the relaxed spring length, L naught. Then to calculate L, we know that it's the ball position minus the spring position, the normal vector of L, which is L over the magnitude of L, and the stretch out length, which is the magnitude of L minus the L naught, which we gave earlier. Then we have our energy update formulas, which are kinetic energy equal 1/2 times the ball's mass times the magnitude of the ball's velocity squared. Then the potential gravitational energy, which is obviously the ball of the mass, the mass of the ball, excuse me, the gravity and the ball's position in the y direction. The spring constant, which is 1/2 times the spring constant, which we gave earlier, as well as the stretch distance, which we solved here, being magnitude of L minus L naught, and then the total energy, which is all three of those combined. Glow script continued. We gave our initial conditions of the energy, and then we gave our energy update formulas over here on the right, and that was used to give our first model of the changes of energy as the ball goes throughout its oscillation. And here's our observation. So we see the green line here is the change in the spring potential energy. The red line is this change in the gravitational energy. The orange line is the change in total energy, and the blue line is the change in kinetic energy. We see the kinetic energy ebbs and flows, as well as the potential spring energy and potential gravitational energy. But the main thing that we notice is that the orange line, which is the change in total energy, remains constant throughout the whole oscillation. Our observations continued. We see in the graph on the left is the x position versus time graph, and the one on the right is the y position versus time graph, with the red line being our experiment from tracker and the blue line being our model from the glow script. We can see that they relatively are very similar. They have similar periods. However, the biggest difference is the y position amplitude, which we think could be because of errors such as not letting go of the mass in a particular way that skewed its amplitude or took energy away from it, which is why there may be a slight difference there. What does it mean? So for a model, we can see that the energy principle is clearly satisfied. The energy principle says that energy cannot be created or destroyed, only transformed from state to state. And we see that throughout this model. All the change in energy is zero, which we can see through the orange line. When the spring potential energy is high, we can see that the gravitational potential energy is low, and that the sum of these, like the integrals of these functions combined together, would be zero, satisfying the energy change principle. Lastly, what does it mean? When we compare the periods of the x position versus time and the y position versus time, we measure from crest to crest or trough to trough. We can see that in the x position, it goes from 0 to 1.5, so around 1.5 seconds for that oscillation. And similar to the y position versus time graph, we see that there is a period of 1.5 seconds, showing that our data just kind of lines up and matches.